the general formula for the derivative.
You know Miss Thompson and I love giving you more than one way to solve something, right?
Yay!
Yay! So,
more than one way.
We have been using the balances to solve equations. We've also just been using pencil and paper. But today we're going to use algebra tiles as well. Yay! Okay.
Just like we did in the beginning when we had ratio tables or tape diagrams or proportions.
No, you don't need to balance out. Okay?
You don't need to. Yeah. Don't mix those up at all.
Listen to me very carefully. On Friday, when you guys had the classwork, I didn't see one single person grab manipulatives, but yet I saw a bunch of people struggling. Okay? It is okay to take whatever tools you have learned to help you solve a problem. Now, of course, when they're really large numbers, you can't use the manipulatives, but you really want to make sure you understand what you're doing. If that means grabbing out a mat, even if you're just, I don't want to say even if you're just playing with it, but even if you just like using it to move the manipulatives around and it helps you understand, use it, okay? I'll tell you, whenever I have a chance to play while doing math, I take it. All right, so on Thursday, when you have your graded classwork, the balances are going to be on your table, and these algebra mats are going to, these equation mats are going to be on your table, and the algebra tiles and the pawns. Use them if you want. Okay, I'm not telling you have to use them because that defeats the purpose of telling you that you can use more than one way of solving things. But know that they are available for you. Okay, so I'm going to just be writing straight on this. Kelly, do me a favor while you're there. Can you hit the light? No. Well, okay, yeah. And then the other one, turn the other one off. Nope, that was on.
Oh, it's much better.
Okay. So I'm going to be writing straight on this, but whatever I write on this, where do you think you should be writing it? In your journals. Okay.
Perfect. Lovely. Yep.
Okay. Alrighty. So the first problem we have. Oh, actually, Miss Russell, take a step back. Yep. These big squares. Anybody remember what these represent? Alex. X squared. Have we been dealing with x squareds at all? No. So we're actually not going to be dealing with these. Everything else you can dump out, and these you can put back in your bag. Okay? Don't need them.
Well, put them back in the bag. I like the plastic ones better. I don't like the foam ones so much.
What?
I don't like the foam ones so much. Like
well, I like the plastic ones, but we don't have enough. That's the problem.
Although the plastic ones are noisy.
Yeah, but then you know they're doing like what they're supposed to be doing. That's what I like.
Yeah.
Okay. Remind me. This represents what? X. Ooh, they're not base 10 blocks. These are algebra blocks. So see if we can fix that a little bit. That represents X. More specifically, it represents a positive or negative?
Positive.
A positive X. And if it's on this side, it represents a negative. This represents a positive 1, and this represents a negative 1. Can these be combined? Okay, no. Why not? Why not? I don't know where the ball is. Somebody help me out. Oh, yay. All right. Why can they're both negative. Why can't I combine them?
Because they're not like terms.
They're not like terms. And you can really see that right here. These are obviously not the same size. If I combine them to make, say, 2 x's, does that make sense?
No.
No. Okay? But yet, when we have just the pencil and paper, sometimes we make that mistake. Okay? So let's set up our first equation. We're going to have, in your journals, write x plus 2x minus x equals 10. And actually, I'm going to, I'm going to put my equal sign in the middle. That makes more sense.
Such a nerd.
Plus 2x. Don't act like you wouldn't have done the same thing.
What?
You would have done exactly.
I would have done something.
Exactly. Okay. So now in this box, we're going to write x plus 2x minus x. And in this box, we're going to represent 10. So how do I represent the x in this box? Throw the ball for me, honey bun. Ben. Okay, green or red? Okay. 1 green bar. Okay. Now I need to represent 2x, so I'm going to use 2 green bars. And then I'm going to put, this is a negative x, so I'm going to put 1 red one. Okay. And then on the other side, I'm going to put 10 bars. No, what am I putting? 10 of the yellow squares. Good. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So now I have my map that shows me this side is equal to this side. But I like for things to be as simple as possible. Can I do any combining here? Ooh, right through your fingertips.
Well, you can combine 2x plus x.
Okay, 2x plus x equals 3x. Okay, can I do any more combining? That makes me my 3x. Sure.
Add it to other x too.
I can add it to the other x too. I can combine all these x's, right? Even though this is negative, does that mean I can't combine them?
It means that if you just add.
It means that I'm adding a negative. And what happens when I add a negative to that positive? What's happening? There's something very specific happening. Because now I have 3 positive x's and 1 negative x. The negative x cancels out 1 positive x. 1 negative, 1 positive cancel out. So I can actually take these away. And I'm left with just what?
X. 2.
I'm left with just an x? No, I'm left with 2 x's. So that x and that x cancel each other out, and I have 2x equals 10. Okay? Now, I have 2 x's, but I want to know how much only 1 x equals. So I need to split these x's into how many groups?
2.
2. And I need to divide the 10s into how many groups? So I have to split these into 2 groups as well. So then how many are now in each group? 5. And how do I represent that mathematically? Sammy.
Well, no, when writing it down?
Yeah.
Oh, you would divide the 2x